Hello, and welcome to Lessons with Laurie, where we look at some of the big ideas in the mathematics curriculum, kindergarten through grade 5. And in this lesson, I want to look at decimals. And the two things that I want to talk about are, first, how do we read decimals correctly? And secondly, what do decimals really mean? And by that I'm asking, how does place value, how does an understanding of place value help us with the meaning of decimals? So let's look at some decimal numbers here. Here are 6 different contexts or situations where students have seen decimals long before they encounter them in the mathematics curriculum at school. We use decimals in our monetary system. We also use decimals in all sorts of measurement situations, whether it's gallons of gasoline, distances that we're traveling, the amount of time it takes to do something, liquid measurement, or even in terms of estimating a population. These are all contexts or situations that students have heard or have seen represented someplace before they encounter them in the mathematics curriculum. Usually somewhere in the middle of 4th grade, when students have begun their study of fractions, they also make the connection between fractions and decimals. And so I'd like to begin by looking at these 2 problems here and ask, how are these 2 problems alike and how are they different? Well, they're alike because they both involve addition, and they're alike because they also involve the same 5 digits or numerals. But they're different in that one involves whole number addition while the other is decimal addition. Now you might be surprised, but I have had students who have answered this question at the right and gotten an answer of a little bit more than 30. And you might say, gosh, Laurie, how do they add these 2 decimal numbers and get an answer that's more than 30? Well, this is what they do. And I've had more than one student who has done this. If they don't understand how place value works with decimal numbers, meaning what's the underlying place value understanding that I need when I'm representing decimals, then they're going to try to apply what they know about whole number addition to decimal addition. And when they do this, they're not really quite sure where to put their decimal point, but they line up the problem, meaning they set up their decimal arithmetic problem the same way they did their whole number problem, and they place the decimal point maybe between the 0 and the 7, although it's just as likely that they could have placed it between the 0 and the 3 as well. So a common error that students will make, and what they're saying is that they don't understand how place value is being used when we're representing decimal numbers. Well, let's talk about how do we even read this problem here. We would read the problem as 2 45/100 added to 6 2/10. I hope you heard the place value numbers when I was reading this. 2 45/100 plus 6 2/10. I know that I can be sloppy and read it as 2.45 plus 6.2. But that's sloppy and it's not accurate, and it's ignoring what we know about place value when we are representing these numbers. So if we read the numbers correctly, we're more likely to be able to add them correctly and make some sense as to why the answer to this problem couldn't possibly be greater than 30. Our answer must be somewhere greater than 8, but less than 9. So we want to make sure that we have some understanding about place value, and it begins with reading the decimals correctly. Well, as I said, students start to explore decimals in 4th grade when they've been working with fractions. And with fractions first, we draw a whole, we divide it into a certain number of equal parts, and then we shade it to represent the fraction. We do the same thing with we do the same thing when we represent decimals. We start with a whole, which you can see here, And if I take one whole and I divide it into 10 equal parts, each one of these parts would be 1/10. If I take each one of these tenths and divide it into 10 equal parts, I now have this small square right here, and I have 100 of them, and we call those hundredths. Whole numbers, tenths, and hundredths. So I've represented the decimal here for tenths. I've also represented the fraction for tenths. I've shaded the same quantity, and you can see that I've represented the fraction 40/100ths and the decimal 40/100ths. So the understanding that students need to have comes from naming them correctly and also being able to sketch these decimals. There's place value at work here. When we sketch them, we have a better understanding of what the digits are representing in each one of those place values. Well, in 5th grade, we then move on to operations with decimals. And as we're working with operations with decimals, we often would use the base 10 pieces that were introduced back in 1st grade in order to represent numbers. But I'd like to show you the place value chart that's very common, and I'm sure you've seen it, the place value chart that we use to represent the various place values with numbers. And I want to make several points about our place value chart. Look at our names here. Hundreds, hundredths, tens, tenths. And you know for sure that our place values are continuing to the left as well as to the right. So we have a place value called thousandths. We also have a place value over here called thousands. I've had more than one student who has said to me, Laurie, how come there isn't one called the once? Meaning they want to have some sort of symmetry here. Tens, tenths, hundreds, hundredths, thousands, thousandths. They want to have something called the once, so there's a symmetry about that decimal point. And what they're not understanding is this idea that it takes 10 of any one of these place values to equal 1 in the next place value, meaning 10 ones will equal 1/10. 10 tens would equal 1/100th. Excuse me, I said that incorrectly. 10 tens would equal 100. If we start to the right of the decimal point with tenths, 10 tenths would equal 1/1. 10 hundredths equals 1/10, and 10 thousandths is equal to 1/100th. So as we move from right to left in our place value chart, each one of these place values is 10 times greater than the place value to its right. Well, if we now move from left to right, notice the operation is division down here. If I take 100 and divide it by 10, I get 10. 10 divided by 10 would give me 1. 1 divided by 10 would give me 1/10. 1/10 divided by 10 would give me 1/100th, and so on. So it's this idea of the 10 to 1 relationship between consecutive place values that's so important. So let's go back to our addition problem. 2 and 45/100ths being added to 6 and 2/10. If I think about place value and how I represent them in my place value chart here and also with my base 10 pieces, you can see that the answer we would get to this addition problem would be 6 and 2. We would get 6 and 2/10 being added to 2 and 45/100ths would be 8 and 65/100ths. As I said, two things that I wanted to look at: how do we read decimal numbers, and also what's the meaning behind it. And the meaning will help us with our operations with decimals. So to summarize, let's look at that number 2 and 45/100ths. That's how we read it. But the meaning that we want about that decimal number is that it's really a mixed number. It's really the whole number 2 and 45 hundredths more, which means it's a number, it's a decimal number somewhere between 2 and 3. In terms of an operation, we could say that it's 2 plus another 45 hundredths. And it also means, look at this other representation, it also means 245 hundredths. And finally, thinking about place value, I want students to recognize that 2 and 45 hundredths is certainly less than 6 and 2/10. So being able to read decimals correctly and understanding the place value relationship that is so important in terms of decimal numbers will help us then be able to perform operations such as addition with decimal numbers. Thank you for being with me. See you again next time.